Hi, I'm Jay Tyler. In this video I'm going to talk about silver solder tarnish, what it is, how does it occur, and why is it more prevalent in some areas and situations than in others. More importantly, what we can do to help minimize it. Here's a lower lingual arch that came in for repair. The band was damaged, but this has been in the mouth for a year and a half. I just checked the billing and it was billed out a year and a half ago. So it's been in the mouth, and you can see the level of, I used to think it was oxidation. I used to think that was silver oxide that got on there, the tarnish, but it's not, it's silver sulfide. Now this is the nickel silver solder that we sell. Now this is a Herbst appliance that came in for repair. It's been in the mouth for over a year, and look at the difference in the tarnish. The silver sulfide on the non-nickel solder, this was made by another lab, this wasn't us, versus the nickel. It just looks better. Now this is an appliance, this is a band and loop that I made, I think for a video. I'm not quite sure what the story is on this, but this has just been sitting around. It's been polished, but it's just been sitting around. I didn't steam clean it, I didn't do anything with it. And look at the difference in the, I mean, look at, it's still got shine, hasn't tarnished hardly at all. And this one's been in the mouth for a year and a half. This is all the nickel silver solder versus the non-nickel silver solder. This is a 56% silver. This is the standard type silver solder that most people use. But look at that difference. So it looks like an alloy that's got silver and nickel in it is the key to all of this. There's a little more to it than that. Let's look at the tarnish itself, find out what it is, and why is it more prevalent in some areas than others. Like I said, I used to think that the tarnish was silver oxide, but I found out it's silver sulfide. This is an oxygen atom, it's a sulfur atom, and these are silver atoms, and they use Ag for that because the Latin word for silver is argentum. So if it were to be silver oxide, there'd be a couple of problems. One is that this is not as readily available in nature as this is. So if you're going to have a reaction with silver between these two atoms here, it's going to prefer this one over this one, since this one's easier to react to it. Now another thing is that if it were oxygen that it was reacting with, then that would not explain why in some areas you have a greater problem with tarnish on silver soldered appliances in some areas than in others, since oxygen is pretty evenly distributed around the world. But sulfur, on the other hand, has higher concentrations in some parts of the world than in others. So sulfur is the culprit. Now, how does this work? Well, it works in the form, sulfur attaches itself to silver in the form of this molecule called hydrogen sulfide. It's a sulfur with two hydrogen atoms attached to it. Now this can be found in decaying organic matter, sulfur hot springs, petroleum refinery places, and natural gas. So if you work around places like, say you're an attendant in a spa that has hot sulfur springs, you're going to be breathing a lot of that gas. You're going to be breathing a lot of hydrogen sulfide, and that's going to tarnish your orthodontic appliance. In natural gas, they put it in that because it smells like rotten eggs. And natural gas itself, usually typically like methane, doesn't have a smell, so they'll put hydrogen sulfide in there to give it a smell so you can tell that the gas is on. Now speaking of it smelling like rotten eggs, you can find it in a lot of foods like eggs, meat, fish, beer, beans, broccoli, cauliflower, cabbage. So if you work around these places, or if you eat a lot of these foods, you're probably going to have a higher concentration of hydrogen sulfide. So these in the mouth, as soon as they start to break down, and they start breaking down in the mouth, you have things like salivary amylase. It's an enzyme that starts breaking foods down. It starts producing hydrogen sulfide, and as soon as that touches silver, it starts making the silver sulfide. So one of the biggest culprits, though, is water in municipalities. So if you have a water system that's got a lot of sulfur in it, it'll smell kind of funky, like, you know, rotten eggs, and taste kind of bad, and a lot of municipalities have trouble getting rid of that. It's very difficult to get rid of, and so if you drink that kind of water, you're going to have a real high concentration of hydrogen sulfide to have to deal with. So that's the big deal right there. So how does this work? Well, you got hydrogen sulfide, and this is what it looks like right here. And then you've got silver. So hydrogen sulfide comes in contact with the silver. It takes 2 silver atoms to hook up to a hydrogen sulfide molecule, and that will yield silver sulfide. And that's what this guy is. Now here's how that works. You've got this floating along in the air. Let's say you ate some beans and you've produced some hydrogen sulfide, and then the hydrogen sulfide's floating along and it sees silver and it goes, oh, I like the bond with these hydrogen atoms right here, but they're not nearly as strong as I could make this bond between the silver and the sulfur. So the sulfur kicks these 2 hydrogen atoms off of here. They become hydrogen gas over here, and they hook on to the silver atoms right here and become silver sulfide. So that's how that works chemically. Now, how does nickel fit into all this? Well, we have an alloy. We don't have a pure metal. Now, if you had this is my representation of an alloy. It's different pieces of metal stuck in here. They're little grains of metal stuck in here or melted together. And this would be the wire, the solder wire. Now, if you had a wire up here that was just silver, it would behave in a certain way. If it was just nickel, it would behave in a certain way. But if you melt them together, it's going to behave entirely different than either one of those. And here's a picture of what that really looks like. And so everything changes. The elasticity, the tensile strength, the ductility, the malleability, everything in an alloy changes from what the individual metals were. Now, instead of it looking like, well, if we get close up on this, we get this. And there's some other elements in there, but we're just going to concentrate on silver and nickel right now. So you get these grain structures. And so this would be a bunch of atoms of silver kind of, stuck together. And here's a bunch of atoms of nickel stuck together, and these form grains, kind of like salt grains in a salt crystal. And so they form, actually it's a crystalline structure, and you get, between these grains, you get these things called metallic bonds. So this metallic bonding not only holds them together, but it has the property of causing an effect on the different individual metals. Now here's a close-up of what that actually looks like. And you can see the different grains, and between those grains, there are these grains, the metallic bonding. Now, what's neat about that is not only does it kind of hold the alloy together, but also because of this bonding, silver no longer acts like silver. Nickel no longer acts just like nickel. Because they are bonded, they take on their own, each other's attributes. So silver will now take on some of the attributes of nickel. Now nickel is not very corrosive. It doesn't tarnish, hardly at all. I mean a little bit, but not much. And so jewelers will use this sometimes to nickel plate silver so that it'll keep the silver from tarnishing, and they can still call it silver. So since silver does take on some of the property of nickel, the alloy itself is going to be leaning more toward nickel than it is silver. So it's not going to be readily available to accept this, the hydrogen sulfide. It's not going to bond to it. So that's basically how it works. So how do you minimize silver solder tarnish? Well, use a nickel-silver alloy and reduce contact with sulfur compounds that produce hydrogen sulfide. So less beer, less beans. Don't drink the sulfonated water. And thank you for watching. I know it's been a little weird. I'm a science nerd. I can't help myself, but thanks anyway, and I'll see you next time.